Well, hello there. Today, we're going to talk about setting up a confidence interval with means. But before we do that, let's review for a moment our process of setting up a confidence interval with proportions. Let's take a look at how this goes, and then we'll compare the proportion procedure to our procedure with means. As you recall, you'll be given a p hat, an n, and a confidence level. For example, you'll be told that you want a 95% confidence level for some proportion. You'll be given an n, interview 500 people, and you'll be given a p hat. Maybe 372 out of those 500 have whatever characteristic it is you want. The idea here is once you test your conditions, you can run the test. But let's go over the conditions first for a proportion. Do you remember what they were? Let's see. We have to have a simple random sample. We have to have our sample less than 1/10 of the population. And then we had n p hat and n1 minus p hat, both greater than 10. As long as those were true, then we could use the normal curve. And we set up this confidence. P hat plus or minus z star times the square root of p hat 1 minus p hat over n. Now, that should make intuitive sense to you, right? I mean, if you sample a proportion and say you want to find the proportion of people who support the president, you're going to ask 1,000 people. And if you ask another sample of 1,000 people, do you think you're going to get exactly the same number? No, of course not. But if you have a nice random sample, if you interview less than 1/10 of the overall population, and if your values here are both more than 10, what you're going to get is a proportion that should be in the middle of a plus or minus range. And that should make sense to you, right? So you always see, well, it's 47% plus or minus 3% at a 95% confidence level or something like that. And that's where the Z star comes from. This is called a one proportion Z interval, okay, or a one prop Z int, right? And the Z star comes from the inverse norm function on your calculator, and this is the one prop Z int function on your calculator. And then you draw your conclusion. And what's kind of cool is the conclusion is the same for both. We are blank percent confident that the interval from blank to blank, whatever you calculate there, captures the true in whatever your parameter is. So the true proportion or the true mean. Now, let's see how all of this works when we talk about means, okay? In this case, you're going to take a sample of people. You'll be given n. You're going to come up with an average for that sample, x bar. You're also going to come up with a standard deviation for that sample, s sub x bar. And you'll be given a confidence level. You'll be told I need to have a 95, 99, 90% confidence level. So let's see. Oh, well, we tested our conditions here. Let's do our conditions over here. Do you remember from chapter 7 what the conditions for a mean were? Well, simple random sample, n less than 1/10 of big N, that's the same. Do you remember the third one? Yeah, n's got to be more than 30. Or n is normal. So you can have a small sample as long as your big population is normally distributed. Okay, so now let's see what happens. Once these are all true, we then set up our interval, x bar plus or minus t star times s of x bar over root n. Okay, so far everything was normal here except t star? And then we have this degrees of freedom, which equals n minus 1. So let's talk about that a little bit and what's going on here. Because once we do this, right, we then use something called a t interval. And of course, our t star comes from the inverse t, which is right on your second distra menu. The t interval and the one prop z, they both come from the stat tests menu. And then this is all the same. So this is how we set up a confidence interval for a mean. Now, what about that t star? Well, it goes a little something like this. When you have a sample, you just have the sample. We don't know the population standard deviation. So we can't really use our normal curve, our z. If we miraculously knew the population standard deviation, then sure, that could be a z star. But really, we're going to use something called a t. Is it like the z? Yes, it's very much like the z. In fact, there's a table of values that you look up just like z. It's treated the same way. It's just that statisticians have decided that when you have means, a sample mean, that you're going to use to set up a confidence interval for a population mean, you need to use what's called the t-table. Now, what about this degrees of freedom? Well, that just has to do with sample size. If you notice, the degrees of freedom is n minus 1. And that just means that tells your reader that you're using the sample size when you calculate the t star, because that's how we do it, right? We use the confidence level and the degrees of freedom. And the degrees of freedom is another way of saying deal with sample size. Okay, so that's what that becomes. And you can use the inverse t on the calculator to get the t star, just like we use the inverse norm to get the z star. And then the t interval gives us our interval, which we then use in our concluding statement. So I'm going to review this for a second, and then in the next video, we're actually going to work through an example. All right, let's go over this one more time. For a proportion, we're given a p hat, an n, and a confidence level. We check our conditions, set up our formula, run the tests, draw the conclusion. For a sample mean, we're given the sample size, the mean, standard deviation, and the confidence level. We check our conditions, set up our formula, and do the t interval to make our conclusion. Everything is very similar, okay? Very similar. All right, and in the next video, we'll work through an example. So, confidence levels for proportion, confidence levels for mean. You can do it. We'll see you next time.